Hi, everyone. Thank you for joining us today for our continuing AU Passes series. Today, we have Matt Wunch from Autodesk. He's going to be giving us a deep dive in Autodesk Reality Capture Solutions. My name is Jason Kunkel. I'm with CAD Microsystems. A little bit about CAD. We are a consulting firm. We specialize in software, training, professional services, and BIM expertise for commercial and public sector customers in the design, build, and operate industries. We have a team of industry recognized experts, published authors, registered architects, engineers, construction experts, and top-rated speakers at AU and BILT. Our customers call us when they're frustrated with their design processes and technology, and they want to improve efficiency, add new capabilities to win more work, and stay competitive. We like to take what we call an educational approach to solving our customers' challenges and are focused on helping them achieve their organization's business goals. As I mentioned here, CAD, education is a core value, and one of the outputs of that is our AU Passes series. We like to empower the design and construction community to share knowledge, to connect with one another by providing platforms such as this. AU Passes came from feedback we got from a lot of our customers and their frustration at not being accepted to speak at AU, not because the presentations and ideas are innovative or relevant, but simply because you can only pack so much content into a 3-day conference. This is our continuing series. We're really excited to have Matt here. And with that, Matt, take it away.
Thank you very much, Jason. And of course, it wouldn't be an Autodesk presentation without the safe harbor statement. So I don't think we're really going to be touching on anything that isn't already out there in the public, but just kind of throwing that up just to cover myself. I like starting with this because when we talk about reality capture solutions with Autodesk, people automatically think point clouds. Well, so you can see this is not a point cloud. This is a mesh, and this was not captured with a laser scanner, and we'll get into that in just a bit. But before we do, a little bit about myself. My name is Matt Wunch. I am a solutions engineer here at Autodesk. I am based out of Connecticut. Been with Autodesk for just shy of 4 years, but come from the industry starting way back, and it kills me to say this, but 1992, AutoCAD 10 DOS, way back in those days. We are going to take a look at the various solutions of reality capture, take a look at what is currently available with some of the workflows and recap and the construction cloud and docs and roadmap items as well. So diving right into it, Recap Pro, right? What is it? How does it work? What can we do with it? Well, Recap Pro is really that solution that I think we all think about when we think about point clouds, but it allows you to take multiple laser scans and consolidate them, register them automatically or manually. But what this creates is what's called structured data. And what that really means is that each of these setups where the laser scan is, that is a single point where we've captured the point cloud, we've captured that 360 photo. And I also mentioned that manual registration. So what you just saw there was the ability to take point clouds, manually register them in the event something isn't recognized. But it takes all these point clouds, creates a single point cloud with those scan stations, with those 360 mirror balls. And again, that is considered structured data. This is typically what we'll take into Revit, into Inventor, into Navis, into any of the solutions, and we're going to talk about that as well. But looking at the point cloud, we can crop it down, clip out just the stuff that we need, focus on those areas that are important to us. There's also Recap Photo. This installs with Recap, and there are two distinct project types that you can create. There's an aerial and there is an object project type, and there are some very distinct differences between the two. Aerial allows you to upload up to 2,000 photos, typically a drone. It is geolocated based on either the metadata, the GPS coordinates within that photo, or coordinate points captured on the site, survey points, for example. On the other hand, we have object projects. These are not tied into any coordinate system. So looking at what you see on the screen here, this memorial, not necessarily needs to be tied into a coordinate system, but we do maybe want that mesh of that. that memorial, that statue. We can upload up to 300 photos there. It does cost 1 token per every 50 photos, so do keep that in mind. And when we process this, this is what's called unstructured data, because unlike what we saw earlier, we don't have that single point setup where we're capturing the 360 photos. We are essentially walking around an object, snapping the photos. In this case, I did this with my iPhone, so it doesn't have to be a high-end camera. It could be your iPhone. You can see all the locations of those photos. What if you want to take the structured scan and the unstructured scan and combine them all together? You can absolutely do that. And we've got ReCap Pro, which allows you to take that unstructured scan as well as the structured scan. So what you're looking at here on the left is the structured scan of the exterior of this building. On the right is the drone flight. So looking at the left-hand side, where we've got those tripods, those laser scanners set up, we're only shooting, kind of towards the parapet of the building. The drone, of course, captures the rooftop. So being able to combine both of these scans is absolutely doable within ReCap Pro. And again, this will take that unstructured and structured scan data, combine it all into a single point cloud. Now, what if you want to do this without really any kind of intervention? You maybe want to do this at scale. We have something called DeCap, and not a lot of people know about DeCap, but it is a command line version of ReCap Pro, which you can see here on the screen. So the old DOS type command prompt, we can take all of our source scans, run them through DeCap, and create these point clouds at scale. There are some customers that I know that are pretty savvy. They have a folder that essentially is listened to. So when employees upload that source data, they're prompted with what's the project name, where do you want the output file, and it does that automatically. So if you got some programmers on staff, you want to get creative and take even more of that load off of that manual intervention there, you could absolutely do that. APS, formerly known as Forge, this is that Autodesk Platform Services. Take those drone photos, those phone photos, those DSLR photos, process them in a similar fashion in the cloud. Little intervention there other than some coding on the back end. You get the same output as before. You get the point clouds, you get your OBJ files, your FBX, your ortho if it's a drone flight. And it also costs 1 token per every 50 photos. All right, taking a look at ReCap and Docs. This is stuff that we have currently available, right? Nothing forward looking here. We'll get to the roadmap stuff a little bit later, but being able to view those point clouds inside of Docs, very similar to what you can do inside of ReCap Pro on your desktop, but without having to install any additional software. All you need is that Docs license, that Docs entitlement, and that point cloud, and you're good to go. You can see all the scan locations on the left-hand side. These are where those tripods were set up, the laser scans were captured, along with those 360 photos. You could jump back and forth between the point cloud, that 360 photo. But what's really cool here is we can start to collaborate with the desktop inside of the cloud. So what I'm doing here, we've got this old logo on our Pier 9 facility in San Francisco. We want to update that logo to the new logo, and we can add a note. We can select the image that we want to have shown in there. You can also add dimensions, call outs, things of that nature. Do keep in mind that the accuracy of your dimensions is going to rely heavily on the density of that point cloud. So the denser the point cloud, the more accurate those points are going to be for that particular roof overhang, for example. Of course, the more sparse that point cloud is, the more difficult it's going to be to grab the right points. Looking at that same point cloud on the desktop side, you can see we've got those dimensions. We've got that call out with the logo. So again, being able to collaborate both from the cloud to the desktop, and also vice versa. As long as we're syncing and pushing those changes back to Construction Cloud, you'll be able to see those changes, those notes. Display parameters, really just more of a quality of life. option here just kind of makes that point cloud a little bit more vibrant on the right-hand side. Same with scan highlighting. Nothing too groundbreaking here, just a quality of life improvement so you can quickly see where those individual scan setups are. Templates is pretty new in the construction cloud. We can set up templates for automatic point cloud extraction, whether it's linear features, points, or 3D objects. Looking at it from left to right here, we have our points. So these could be manholes, these could be light poles, stop signs, etc. Specify the color, specify the feature code. So when you export this, bring it into Civil 3D, reads those feature codes. So your fire hydrant is actually a fire hydrant object inside of Civil 3D and not just a point or a block. It can be actual COGO point. Again, reading that feature code. In the middle, we have the line. So if we're looking at, say, edge of curb, top curb, back curb, extracting those linear features, same thing. Set a color, set a feature code, bring that into Civil 3D, automatically maps out to the right properties. And the 3D objects, in this case, we're looking at an ADA ramp, but this could be any kind of 3D object, really. And essentially, what this is a series of points connecting these lines, and we'll see a little bit of that in just a moment, but being able to extract more information than just a point, than just a line. All right, so when we export this information, we have DXF files. DXF files are simply 3D polylines. Land XML, that's going to give you feature lines, and CSV will provide you with points, coordinates, description, etc. Nice, looking at some of the workflows here. Automatic ground point classification was introduced not too long ago, probably about a year or so maybe. Great thing about this is it automatically separates your ground points from the rest of the point cloud. So taking all that surface information and delineating it from the utility poles, the noise of the cars as they're captured, as they're driving by, the vegetation, etc. So why is this important? Well, when we take this point cloud into Civil 3D, which we'll see a little bit later, we can create a surface just from that. We don't have to worry about any kind of interpolation methods or trying to extract other bits of information, because all we have are the ground points at that point. So it makes it very easy, very fast to extract and create surface from that point cloud. Manual classification, in the event that the automatic classification doesn't quite grab everything, or you want just a particular portion of a site, of a building, whatever it happens to be, you can do that. And this is, again, one of those relatively new features, 2024-ish came out right after the automatic classification, just giving you more control, more flexibility over that point cloud and what you want to extract from it, what is important to you. Here's a quick example of what that could look like, right? So this is that Brownsville point cloud. I'm sure you've all probably seen at this point, but there's the buildings, there's the trees, there's the cars, the utility poles, the cell tower, all classified. This was done primarily by manual classification, with the exception of the ground. That was automatic classification. Intelligent decimation. This allows you to take that point cloud. In this case, we're looking at the ground points here, but we can take that point cloud and we can decimate it by an approximate percentage or an approximate number of points. So giving you even more control over that point cloud, especially when we bring that into Civil 3D. We don't need the millions and millions of points that a point cloud typically has. And quite frankly, no surveyor is ever going to capture that many points. So eliminate points where it makes sense. Try to avoid those MMS files. And here is, I think, a really good example of that intelligent decimation in practice here. So this particular point cloud is about 6 square miles. It's a portion of South Carolina. You can see there's a river running through the middle of it. East and west, relatively flat, right? So intelligent decimation applied to the east and west side, extracting out majority of the points because it is relatively flat, but then maintaining more points where that river is and all the branches of that river, because we want more definition there. So this is a great example of intelligent decimation and why you would use that. Feature extraction, template, and the schema library. So you saw this a little bit earlier with the those templates. Those are new. This is all inside of the cloud, extracting parts of our point cloud. In this case, we're taking a look at part of the curb here, and we can set those top of curb, bottom of curb, and again, tie those into your feature codes. Set that, of course, set it up as a template first, so you don't have to do all this. But then let the AI and the machine learning behind the scenes run along that curb, that gutter, automatically adjusting as it goes along. We'll see that in just a second here. Just jump a little forward here, right? So you see those points, and it's going to just keep snapping to that curb, so we can easily take that information to our design file to Civil 3D as that land XML feature line, or if you want the DXF file, you can do that as well. So point features work a little bit different. You're essentially specifying a point on that utility pole, on that fire hydrant, on that light pole, whatever it happens to be. Again, having your template already set up is going to be key. But then once you specify that point, you can then move that point towards the approximate center, because again, this is a laser scan. This isn't, it's not X-ray. So there's that. Actually, jump back real quick here. Right, there's that point after it's been moved towards the center, because again, we're only snapping to the point itself. It doesn't automatically find the center of that object, at least not yet. Hopefully it will. But that's what you're going to have to do, is just move that point to the center after you tag that particular object. ADA ramp extraction. I talked about that template earlier, right? So it has those points, has those connecting lines between the points. You can add additional points to that if you want to make that shape more complex, make it larger, grab something extra. But essentially, we're doing kind of the same thing that we saw with the point extraction. We're moving those points to particular spots on that point cloud, and we can then extract all this information and use that as part of our surface creation inside of Civil 3D. Freeform is very similar to the ADA ramp. It's just that, it's freeform. Works very much the same way, but it doesn't have a template, right? So we're just kind of randomly picking points here along the roadway, along that crosswalk, bottom of the curb, and going to use that to extract that portion of the point cloud. And advanced, there we go. All right, I didn't click the button. So CSV export, right? This is where we're going to grab our information, but looking at that CSV file, again, it's going to have those points, those coordinates, that description that you can then take into Civil 3D or any other application where you may need that CSV file. So Civil 3D, right? We can take this and take that point cloud into Civil 3D. And I'm just going to apologize for the language. It is in French. I got this from my French colleagues, but the workflow is the same. Dialog box is the same. But we're taking that point cloud into Civil 3D, create a surface. And remember, using that automatic ground classification, strip out all the noise, strip out all the buildings. So when you do create that point cloud, you're using that no filter option, because all you have are ground points. So we don't have to mess around with that interpolation and get sort of a close, accurate representation of the surface, because all we're using is the ground points. It's going to be accurate based on that point cloud. So make sure you take advantage of the automatic classification. AutoCAD, of course, we can bring it into AutoCAD because, I mean, if we can bring it into Civil 3D, we can absolutely bring it into AutoCAD. With AutoCAD, though, you've got some tools here. Of course, you can do this in Civil 3D, but looking at that point cloud, slicing it, dicing it, however you want, however you need, and just making that drafting a lot more efficient for you. And I've got a couple of examples here. I'm just going to skip ahead. Section lines within that point cloud. It's kind of a misleading label, but essentially what that means is we're looking at the section of that point cloud. So whether it's a top-down slice section of that, looking at the floor plan, or if we're looking at a vertical slice section of the facade, or a slice through the building, taking that point cloud, generating line work based off of those points to speed up that process of going from scan to design. Of course, the density of your point cloud is always going to be key here. The more dense the point cloud is, the more accurate those section lines are going to be. This is an old video. If you have used InfraWorks, you'd notice that icon is old. The graphics here are old, but it's important to point this out because this is still part of InfraWorks. And this really kind of set the stage for everything else that we've seen so far, the linear feature extraction, the automatic separation of the ground points from everything else. So you can take advantage of this workflow still today in the latest version of InfraWorks. And again, this will create a surface based off of those ground points. It'll also start to identify objects such as trees, signs. It's not going to be 100% accurate, I'll tell you that right off the bat, but if it can place light poles and stop signs for you, and maybe all you have to do is just kind of swap out some of those elements, well, that's a good chunk of the workflow already done for you. Linear feature extraction here, looking at very similar kind of interface as what we saw in the recap inside of Docs. There's that section view of a curb line, for example. Very similar workflow. You can also extract pavement striping from that point cloud as well. So again, it's an older video, but it really just kind of sets the stage of, this has been a capability for a while. So do take advantage of this. It is still inside of InfraWorks. Oh, then there's that car again, right? So it's not just point clouds, but also that mesh object, right? We can take those mesh reconstructions, bring that into InfraWorks, bring it into Revit, even bring it into Forma, and really start to build out, in this case, build out that scene to tell that story of that particular project. Mentioned Forma, right? So taking that same mesh of the NASCAR race car there, bringing that into Forma. Of course, you probably want to do something a little bit bigger, maybe a building, to really start to take advantage of Forma's capabilities. But this just goes to the point that we can take those reality capture meshes in other places other than InfraWorks, other than Revit. And what's really cool about this is that mesh goes along for the ride inside of Revit when we push that design from Forma to Revit. Of course, again, you'd want to have probably something bigger, like a building or a monument of some sort, to really kind of justify the use of the mesh there. But just kind of goes to show, illustrate the point that we can take that OBJ file elsewhere. I'm going to kind of skim through this one here because there's really nothing earth-shattering here, but being able to bring that point cloud into Revit, we can section up that point cloud, looking at it in a number of ways, and being able to utilize that point cloud to start to build out our Revit model, the floors, the walls, the doors, the windows, etc. Point layout is not really it's not a recap solution, but it is a reality capture type of solution. In this particular example, I'm using it to analyze the deviation from the as designed Revit model versus the as built laser scan. And just by simply bringing those two together, we can start to see where that floor is flat, where it slopes down, by how much, and really start to ensure that our design is being constructed the way we intend it to. So not really not a recap solution, but it does utilize point clouds, and did want to point this out. All right, desktop software, we've seen a bunch of this already. Did leave out 3ds Max. I did leave out Inventor. However, Inventor is not part of the AEC collection, but just did want to make that clear that point clouds are not just for these solutions, but for others as well. All right, looking at the roadmap stuff here, this is all public facing, so nothing secret here, but I gave this one its own slide because I think it's really important. Even though rail design isn't the hot topic in the States here, as popular as it is in other countries, but I did want to point this out. We have linear feature extraction now. Rail extraction is certainly a hot topic, grabbing those sleepers, grabbing the top of the rails, etc., to be able to build out that design. Back in, I think it was late March, mid-March, we acquired Point Fuse, and this is still all kind of being figured out how it's all going to play in the overall solutions here. Is it going to be cloud? Is it going to be desktop? Is it going to be hybrid? We don't know yet. And those who do know are not saying anything at the moment. But what Point Fuse is it takes those point clouds and can automatically segment those point clouds into 3D mesh models. So being able to extract, say, the furniture as a mesh from the bookcases, from the floor, from the walls. So being able to do a lot of that sort of automatic classification like we saw earlier with just the ground points, but being able to do this at a greater scale and being able to create 3D models from that. All right, so there's that quick overview of what Point Fuse is. And again, still yet to be seen, determined how this all plays into the grand scheme of things here. Also on the roadmap, I just picked out a few of them that I thought were really cool and or hot topics here. Scan to mesh, this one's been on the list since 2022 with that Point Fuse acquisition. Well, I think, putting on my former BIM manager hat, I could see this being ramped up pretty quickly. But again, safe harbor statement in effect here. Don't really know what's going on. Vertical coordinate systems as well, looking at support for that. So not just the X and Y, but also the vertical as well. Point clouds and model coordination is a huge topic of discussion. It's a huge wish list item. Seems like a lot of the customers that I talk to are looking for this sooner rather than later. And then that, being able to measure areas of that point cloud, currently can't do that. That is also on the roadmap. And these are all public facing roadmap ideas that I pulled here, so nothing confidential. So this brings me close to the end here, and wanted to leave you with a final thought, and that is, what else can you do with reality capture? Right? We talked about civil, we talked about buildings a lot, but there's so much more. It's not just the AEC, but video games, movies, and TV. If you want to maybe kick up your marketing to another level by bringing in a combination of that as designed model with the existing surrounding context of the site as it is currently, bring that in as a 3D asset. Digital cities, space utilization. This is just a few that I was able to think of. I'm sure you all have a lot more ideas that you can use reality capture on, and start to incorporate that into your workflows. And with that, I'm going to kick it back to Jason.
Awesome, Matt. Thanks a lot. That was a lot. There's a lot of motion and movement going on there.
It's a deep dive.
Yeah. A couple questions I jotted down as you're going through. When that first DeCap slide came up, I thought you had a typo, but obviously you did not. I quickly looked at the web page. It looks like it's kind of got its own syntax for essentially command line callouts there.
Right. Yep.
Do you know? Can you? Because it feels like so much of the power and new stuff is coming from Docs. Can you use DeCap on a Docs hosted set of point clouds if you're using desktop connector or something, or is that going to get grouchy?
So DeCap is going to run on the source files. So not the point clouds themselves, but say like you go out and capture a site with a Faro scanner that has those FLS files. So that's what you're going to be running that on. Yes, you can absolutely do it if those files are hosted in Docs, but also cached to your machine through desktop connector. I wouldn't recommend it. I would say just run it off your machine with those files locally. At that point, once that point cloud is generated, whether you decide to push that entire point cloud project up to Docs or do a little trimming, decimating, what have you, before pushing it up. But that's what I would recommend. I would recommend doing it local. Certainly store those FLS files on Docs so you have them if anyone needs to access them at any point, but do that processing local.
Okay, awesome. Speaking of local processing, any specific recommendations around hardware needs other than a really giant hard drive?
Hard drive is definitely a big thing there, especially with point clouds. I mean, some of the examples I shown were relatively small, a gig, 2 gigs maybe, but they could be upwards of hundreds of gigs, terabyte in size. So certainly the more space you can afford for that machine, the better. When it comes to viewing those point clouds from Docs, that all relies on the GPU of the computer. So nothing is being downloaded. We're not downloading and caching those point clouds. We're simply streaming them through the GPU. So do my NVIDIA stock a nice little favor and purchase some of those. Those will certainly help you out. But in all seriousness, it just comes down to whatever you can afford for that GPU when it comes to streaming. You can get away with a relatively modest system for streaming, but certainly when it comes to processing, try to get the most bang for your buck in terms of the hard drive itself. But this is a good reminder to everyone that once you have those point clouds, throw them up in Docs. There's no storage caps in Docs other than the largest file you can put up there is 5 terabytes, and that is tera with a T. We're not talking gigabytes, but terabytes, a single file. So you're not limited really to storage. So push that, offload that data to Docs when you're done on your machine.
Okay, awesome. I think NVIDIA stock's doing fine without that mentioned, by the way.
It's taken a little dip recently, but
well, that kind of related to the whole AI machine learning stuff, right? The feature codes and classifications look fascinating. In terms of the templates, are there some pre-made templates, or do people have to go up and kind of from scratch make their own classifications up on cloud?
That's a good question, and honestly, I don't even recall, because I've been playing around with my own templates and creating stuff from day one, and being part of the beta team. I honestly don't even remember at this point. But you can find out for yourself just by cracking open one of those RCP files in your Docs project and check and see if there are any templates in there. I think the ADA ramp is already there. I don't recall if there's anything preset for points or linear features. However, once you do define one, you can take that to other projects, simply import it into other Docs projects without a problem.
Awesome. Very, very cool. Last question I got here. Aside from the iPhone that you mentioned for that memorial, it seems like everything is pretty hardware agnostic. Is there anything specific people need to look for in terms of the actual capture devices?
No, we do support a number of file formats, 2-3 dozen or so for reality capture. Of course, the E5.7, which is kind of like the DXF or the FBX version of generic file formats. Yeah, I don't believe there's really any kind of limitations in terms of manufacturers of different scanners or anything like that.
Awesome, perfect. Brilliant, that was great. Really appreciate it, Matt.
Yeah, absolutely, absolutely.
All right. So with that, let's start wrapping up the presentation here. I wanted to thank everybody for joining us. One mention quick about our BIMxt network. We have some in-person events on the cities on the left. It's kind of an evolution of our Revit user groups, but continuation of our desire to kind of educate the industry and bring people together. We've got our in-person events. We have our BIMxt online events, which meet quarterly, and then we've got our LinkedIn group that supports it all, where you can find announcements and anything. Any of this stuff, feel free to come to our website and sign up and get notifications. But other than that, thanks so much for joining us, and we look forward to seeing you next time.